At this point, we have for each movie I computed the Dij for all the j's out there. I've got a list of numbers. Let's arrange these in descending orders. Okay, these are the Dij values, and maybe movies 5, 8, 10, 2, and so on, with respect to movie, say I equal 1, the first movie. Okay. All right, very good. If you look at this and say, some of these are real big numbers, some of these are real small numbers, real negative numbers. Again, remember, this actually can be either a positive or a negative value. So we will say those that are very positive and those that are very negative are both useful, because they are very similar or very dissimilar movies. So let's just look at the absolute value of Dij's. And we want those that are big to be included. Okay, so we'll pick the top, say, 5 movies. Top either meaning they are really big here or really big here. Okay, and that will define what we call the neighborhood, a list of other movies with respect to this given movie I. So for example, L1 could be movies 5 and 8. Let's say there's a movie 21 down here, 21. Okay, now I say, who determines how big the set is? How long is the list? Who determines basically the cutoff threshold of the Dij value? Well, the one that will be determining this is you, okay, the recommender. So there are quite a few rules and guidelines in determining how big is this list. If you make it too big, then you are indeed incorporating the comparative information with respect to many other movies, but some of them are so weakly coupled with this movie that it doesn't quite matter. So just adding too much noise. On the other hand, if you include too few neighborhood movies, then you're not fully leveraging all the information, and then you are losing precious information about other movies. So that's not good either. We won't have time to go into the exact art of picking the right size, and that's indeed part of the reasons why it took many computation for these teams to compete in the Netflix prize. But roughly speaking, the idea is that if you like movies, say Schindler's List, and say Life is Beautiful Life, then maybe you like Dr. Zhivago. If you dislike E.T. or dislike a Lion King, then maybe you also dislike, say, Toy Story. Okay. So that's the idea. The idea is that we're going to look at all these movies as points in the space. Those that are very close by this cosine theta metric, we'll call them neighbors. And therefore, for each movie I, we will define a neighborhood by the absolute value of these cosine coefficient values.